All right. So this is a session about Kubernetes. Before I jump into that, let me just tell a few words about who am I, except that I love hot dogs. So I'm a part of what we call the Cloud Native group in Azure. I work closely with the guys that does all the engineering behind the scenes, from Azure Kubernetes Services, ACS Engine, and basically all the guys building all the cool stuff, right? But also the stuff that we talk about when it comes to Kubernetes development tools, Draft, Helm, Brigade, Kashti, and if you're familiar with those words, is something that my team is looking at as well. I work in an area I call Western Europe. It basically means that I focus with larger customers and partners and help them get on board on Azure from an infrastructure point of view when it comes to containers, and also how do they host the code on Azure, and how do we do that in terms of best practices and so forth. I've been working on Azure for the last 10 years. Started working on Azure when it was actually called Red Dog before as well, if you're familiar with that. But before I jump into the presentation, how many of you guys are on Azure today? Can you raise your hand? Very cool. How many of you guys are on Google? Boo, you can go out. Nah, kidding. Cool. How many of you guys that raised your hands that actually also work with Kubernetes today? All right. Good, fair number. Good. And is that Kubernetes on Azure? Raise your hand again. Very good. All right, so let's go into the agenda. So overall, I'm going to be talking about how we do cloud modernization and how we basically migrate applications to Azure as well. We will be talking about the different solutions we have from a container perspective. We have a lot, by the way, and also which one should you pick, and that's probably one of the hardest things to do when it comes to Azure. If you go to Azure, how should you host it? Well, it really depends on the state, but we'll get into that. We will be talking about the different container solutions we have from a Kubernetes point of view. We will be talking about networking. Networking is key when it comes to basically everything. What's the differences we do? And how do we do a high availability architecture when it comes to hosting applications on Azure? When I'm done with that, we're going to be talking about the Kubernetes development tools, Helm, Draft. How many of you guys are familiar with Helm and Draft? There's a few ones. Okay, good. And then we're going to be touch basing all the pipelines as well, how we basically built that. I only have 40 minutes to sort of go through all of this, so it will be going a bit fast. If there's going to be a few questions, come over. I'm going to be standing at a Microsoft booth, so come down, and there's a few guys down there to help you guys as well. So let's jump into it. So which platform should I basically choose when I go into Azure? So one of the first things we look at, this is my only marketing slide, by the way. So, but the only thing, what I like about this slide is that by 2020, 50% of all the applications running, we expect to run in some context of a containerized applications. That's what we foresee, that is what we believe in, and that's why we're also building and emphasizing the need of doing cloud modernization. I bet a lot of you guys still have a lot of legacy applications that we need to modernize, and how should we host that? Should we still do it traditionally wise, as we do in our basement? Or should we put it into Azure, and how can we do it in a cool way? So before I go to my next slide, how many container solutions do we have on Azure today? Quick question. Give me a number. I like that. So one guy laughed. We have too many. That's the obvious reason. And the reason for that is because historical reasons, there's different choices for that. And we have a lot of services up here. We're going to be drilling into each of them later on. So if you look at the left side, we have our partner services. That means if you traditionally like to run your OpenShift, your Pivotal, or your Swarm or Mesosphere, you can still do that on base. It will be a marketplace service. We have an offering called Azure Container Services today, which is the first version we had. It's basically a cluster running, but you could choose the orchestrator, which one you want to run with. You can choose Swarm, DCOS, or Kubernetes. The reason why we had that, and this is maybe around 2 years ago, is because we didn't know who would win the container war. So we need to build this platform. So that's why we chose to do that. Now, today, the obvious winner is, of course, Kubernetes, and we're going to be drilling into that. So that's the left side. So we can basically host everything I have. The last thing I just wanted to mention as well is the OpenShift. If customers are running on OpenShift today, we will also be offering a managed OpenShift platform. And what does that mean? That means that we will host the whole platform on your behalf. The control plane, you will not be able to see it, you will not be able to touch it or do anything about it, but we will host it on your behalf. It's actually quite similar to the one that's blinking, the Azure Kubernetes Services. That's the one we're going to be talking about today. But also, if you talk about Service Fabric, Service Fabric is, we approximately say that 1/3 of all Azure workloads run on Service Fabric today. It's super bulletproof, it's mature, it's pretty advanced when it comes to the orchestration and so forth, and there's different use cases when you should go for that one. Azure Batch, the one on the right side, is our HPC offering, meaning that you have HPC you need to be doing on GPU-based services or CPU, you can choose that one. App Services is a service we also offer for customers, but we typically see it being used if you have a more simple application. That means you have a container, you can shoot it up and host that. It's pretty basic, but we still have a need and urge for that. So we still need to have that running there. Especially if you have a multi-tiered application, you need to do a lot of advanced stuff, that might not be the best fit. On the right side, we have our Azure Container Registry. And how many of you guys saw that we bought GitHub for a while ago? So what we will be doing within the next half year is to create what we call GitHub as for businesses. That means we'll shut it down and we'll completely run with Azure Container Registry and we'll go with that. That's of course a lie. I'm just kidding. Of course we're not going to trust that. GitHub as for business, right? No, I'm kidding. I so hope that this wasn't recorded. Anyway, but of course GitHub is still going to be there. There's some cool scenarios that we're looking at and how we can actually integrate those guys federation-wise and so forth into Azure and make it more seamlessly and sexy in that sense. At the bottom, we have different kinds of, let's say, OSs as well. I wouldn't really call Azure Container Instances OSs, but it's a small footprint in how we can do lightweight containers. It's a standalone service, it's a small container, it supports Windows, it supports Linux, and I'll show you and talk about how we can actually integrate that directly into AKS. Virtual machines, when you build a cluster, we need to have virtual machines behind the scenes running. And they comes all different sizes, shapes, and which we're also going to be talking about. On the top, we also have something called OSPA, which is our open source broker. When you run a cluster, you still want to be accessing services that we have as a native platform in Azure. So running OSPA is an open source project we have, will give you directly access for your clusters and running and accessing these. And these, well, the main goal is basically to have all the services we have in there and being put that directly into Kubernetes, for example. So Kubernetes is the one we are betting on. Brandon Burns, which is one of the inventors of Kubernetes, is the lead engineering guy from us, and he's the guy leading the team. The guys actually building the service as well is a team called Days. Days is a company we bought a while ago, and it's actually also those guys that invented Helm, if you're familiar with those guys. So those guys are actually sitting and building that, and are actually non-Microsoft roots as well, which is actually quite cool to also talk about the openness that we have in the open source space. So why are we talking about and why are we betting on Kubernetes? We see the industry winning. We see it being the one that actually won the war, and we also see all the other vendors are putting all their cool gadgets on top of Kubernetes and utilizing those services as well. So before I go into the next slide, so how many are not familiar with containers today? Can you raise your hands? Good. That's a high number. That's good. So to roughly stated, what we typically see when you run containers in Azure, we see customers using different kinds of use cases. When you run and you want to run a high availability cluster, you should also have a minimum of 2 clusters running in each region. We are still a cloud vendor. There can still happen outages, so you still need to figure out how you can do a failover and so forth. So this is just a few examples how we can run a container, and as a container, we basically take the applications, put it inside a container, and make it really, really lightweight. That's the whole idea about how to run this. So let's start doing all the fun stuff. So let me just talk about one-on-one about Kubernetes today. So if you look on the left side here, we have our API, we have our masters. Can I see my mouse here? Yeah. So we have our master services running on here in the control plane. what we're doing with our AKS services is that we do not allow you to access the control plane. You cannot see it, you cannot feel it, you cannot query, you cannot do anything about it. It's running there, and I'll show you how you actually can enable monitoring with it later on. We have what we call worker nodes that expose to the outside world. These worker nodes is what you are capable of seeing and touching. That's what you work with on a daily basis, and these is the ones you need to be scaling as well. We're going to be doing some changes to our backend, because one of the things that we're challenging is the amount of speed we can do when it comes to scaling. When you want to be scaling, you want to do it pretty fast. So in the next couple of weeks, we will be upgrading how we do that today. And especially for Black Friday scenarios, you want to be able to scale and so forth. So we're changing some of our backend into that. And what we actually are doing is basically creating a VHD, putting all the stuff inside of that, where it's basically pre-baked. And that means that you do not have to go out and have a shell of the VM, download the VM, download the Docker runtime environment, Kubelet, patch it, update it, and shoot it out, and then 50 minutes it's up and running. That's just not acceptable for a modern world and hosting, how you host applications. So we're changing that, and some of the approaches that we're looking at it, what if we could change the entire way of doing Kubernetes by removing the need of having nodes running in the background. And nodes in Azure today are based on Ubuntu, by the way. So let's say that we remove that from the equation and now just have a pure Azure container instances. That's something that we're looking at. If we can replace that, that'll also mean that we will be doing it differently towards what Google is doing and what Amazon is doing. Why are we thinking about this? Agility. That basically means that we can spin up an image of you guys that have been running with Azure container instances. We can spin up an image in about 15 seconds. That's extremely fast. And that means it will be scalable, it will be, and also GPU based eventually next year. So there's a lot of cool scenarios that we're going to be using and showing. And I will go into details in a minute. So this is just the overview about what we have. We also have the etcd, which is basically the brain of Kubernetes. We have that running in a high availability cluster. So in case a fallout or something goes wrong, we still have that backed up locally in our engine side. Let's go to the next one here. So why Kubernetes? First of all, we need to focus about how we do upgrades and manage our services. When I say that, it's not just your Kubernetes side of it, but it's also applications. How do you do that today? Do you do it manually? I've seen some of the largest, let's say, beer companies in the world, how they patch some of the services. It's one dude, one terminal, upgrade, hit the enter, that's it. To extremely advanced CI/DC pipelines and Azure DevOps and Jenkins and so forth. And also, how do I build a high availability and highly scalable cluster as well? Black Friday scenarios. I need predictable boost. Well, change those you can easily do. And if anything goes wrong, I also wanted to be able to fail over to another cluster. That's maybe preferably active. And if a pod fails, how do I get out of that again? Self-healing and so forth. And last and not least is also monitoring. We don't really care about which monitor solutions you use. You should use whatever you feel that you're comfortable with. We just provide a few solutions out of the box up there. Also a solution that we call Container Insights. So this is just a quick overview about how you can actually see the different services and the architecture that we have in Azure. If we go into Azure about going back to the services, a lot of customers are still saying, well, Microsoft, I know that you're hosting my control plane, but I still want to be accessing my metrics from my control plane. I want to be seeing my logs, my scheduling, my API, and my control manager. And the control manager is one that also handles all the control plane functionalities on Azure and all that interaction. But you can do that now and actually go in directly do that. The thing I would be cautious about, think about the things that you want to be activating if you do that. Because you don't want to be collecting too many logs, because Kubernetes can be loudy and create a lot of logs. So you don't want to be getting a big bill just because you decided to do this. What should you be monitoring? Classical, disk space. Disk space is extremely important. When you run on Kubernetes clusters and you have nodes running in the background, think about the disk space you have. Run cleanup jobs once in a while. Think about that, garbage collecting and so forth. Traditional things, how does your application work? How many of you guys are working with YAML today? Can you raise your hand? YAML files. How many of you guys love doing YAML files? One guy, I don't believe you. I don't believe that's a lie. So, but that's also an issue. Because it's so depending if you write correct YAML files. You have an application. If you haven't set the limitations on CPU and memory, if you have a memory leak in the application, you could basically swallow the whole cluster and shut it down. So some of the guys, hopefully you that raise your hand down there, would also running Visual Studio Code, and then it automatically comes in and saying, remember to set the limitations. I've seen so many customers having clusters broken just because they didn't set that, because some developer had a memory leak and the application went wild. Someone is nodding their head in the back. Yeah, so that has been seen for. So that's good practices. File systems, pods, IOPS. Typically, when you, as a developer, start looking at code and how you want to be hosting your applications, how should you host those guys as well? It's sometimes a bit hard because you need to figure out which T-search size you want to be running with. Should I have GPU-backed VM? Should I have highly scalable? I need 28 gigs of RAM. I need a lot of CPUs and so forth. How should I do this? And that's what my typical recommendation is. You need to try a few times in order to get it right. That's typically what we see because it's hard to predict these features. And also another thing that I want to be talking about is also how we do scalability in jobs. How many of you guys that raise your hands that are working with Kubernetes today are doing cron jobs? 1, 2, good guys. So some of the things we're looking at, what if we can change all that scenarios and boost jobs into a container and make that run? That is interesting as well, and we're going to be drilling into that later in a minute. So, networking. When we run networking in Azure, there's 2 different networking steps you need to consider. We have something called basic networking. And this is important, guys. So when you run basic, if you choose the basic installation, it means it will be running on Kubelet. Kubelet, what it does is a really lightweight, simple service running. It comes up with 2 CIDRs, and you need to manage those. It's hard to pipe those directly into your networking in terms of you want to be connecting to on-premises services, express route, networking, and peering, VNets, and so forth. You need to create a lot of custom rule sets, and that's a hard one to do. You need to be really careful what you're doing. It is doable. I've seen it work, but it's really hard to maintain. So typically what we recommend is look at the advanced networking stuff. It's based on the upstream version of CNI. It's also the one we port in. And by the way, Kubernetes AKS, the one we of course use all the upstream versions. That we do not deviate from that. So everything that's ported in there is also what we do. So everything needs to be fixed. It needs to be fixed upstream, and then we'll port it in afterwards. Okay. We'll fix the plumbing in our end if something goes wrong there, but we need to follow everything upstream. And that's the same as Google and Amazon are doing as well. So from advanced networking when it comes to Azure, why? Express route, peering on premises. You need to have clusters to talk to on-premises through DNS. You need to be able to scale from a networking, and you have different networking services that need to be able to talk to each other as well. So let me just show this. I hate talking too much slides, so let me show you. All right. So let me see if I have anything over. Is this too small? Is it okay? So now I'm going into my networking. So what we have in here is different kinds of features. So we can see that we have already a lot of IPs addressed. So by default, each node, if you don't edit the template, will have 30 addresses reserved for that given pod. You can go into the ARM template and edit that to 110, I think the latest number is. So that's something you need to think of. So a pod reserves an IP address, okay? But why should you use advanced networking? First of all, we can use the DDoS protection. We have firewall rules we can go in and adapt. You can create DNS names in here. But the cool thing is actually my service endpoints. So service endpoints gives you the possibility to actually being able to talk directly to our services on in Azure using Azure Backbone directly to the storage accounts. So you don't need to go over the internet to access another service, which also wouldn't make much sense. But this is a cool way to keep everything private. And that's also something that we will eventually provide is a fully private Kubernetes cluster. There are some stuff that we need to do from getting services out of like pods and different kinds of software. So we need to expose some of the endpoints that we have running in our cluster. So that's an extremely important thing when it comes to that. So let's go back to the presentation here. So container instances, what is it? Azure Container Instances is sort of the new thing that we emphasize. Why is that keep popping up? That's a bit annoying. So that was too fast. So when you run cron jobs, that's fine, and it's still using resources based on your Kubernetes cluster. But if you now could scale Infinited and just have a lot of pods running a lot of jobs in there for you, on average, we typically see customers that are quite mature in this sense. It has a lifespan of 1 hour. That's typical the use scenario it has. We see it doing jobs calculation on CPU. The t-shirt size is based on, I think it's 4 cores and 16 gigs of RAM. That's the highest one we have now. That will grow up. Also, if you run into, let me just show you this when you create a cluster as well, because there's different use cases that we have. So let's say that you run into Kubernetes and you want to be spinning up a new service. What you can do is also choose the t-shirt size, which I talked about before. So depending on the need and what you're going to be doing in your cluster, and if my button just would work, it comes in here. So I can basically select the kind of IOPS I want to have, my data disk, how I want to be doing that, my RAM, a CPU, and t-shirt size from my local disk and CPU. And this is important. You need to consider because you can choose whatever model you want. And this can be the baseline for all the clusters that you're going to be doing. But if you look at ACI here, is that you can actually now go in and add our Azure Container Instances to your Kubernetes cluster. That means you add a connector, and that connector will now have access to all the container instances. I call them, they are preheated, so when you order in or boot it up, they'll just go directly in and spin them up. And how would this look like on Azure? So let me show you this. So let's start with here. And let's just check. So what I'm going to be doing now here is just to show you guys how that actually looks like. Okay, here's a cool tip and trick as well. So how many of you guys are familiar with Azure Interactive? It's a nice tool when you have for Azure in order to do auto completion of services that you're running in Azure. So let me just move this a little bit so I have a room for a little bit more. Zoom in. So here I have. So now I can basically start typing and it will start auto completing all the services you have. Every time you use Azure, you only use the GUI once. That's just to learn how it works. You always do stuff in CLI. Remember that. Always, always CLI. Never use the GUI, except that you really want to do something quickly and easy and simple. So here I have the CLI, and I can do some stuff. So let me just exit out of this, and we'll come back to that in a minute. So in this case, I want to be seeing that my nodes, what they're doing. So my runtime environment currently is running on Ubuntu. I also have what I call a virtual kubelet. The virtual kubelet is the connector that connects myself to my Azure Container Instances. They can both be Linux-based, they can be Windows-based. Why? Because there's still a need for Windows when it comes to container platforms. Okay? We still have that Azure, especially in the Nordics. There's a lot of .NET customers still want to be utilized now. So we can still fully do that. So if you want to be installing that, it's actually quite simple how you can do that. Let me just quickly show you that. So what you need to do is go into your existing Azure Kubernetes cluster, Azure AKS, and then we have something called the Cloud Connector, and then you will select the name, and you can see it's saying required, and the resource group, and then we'll go in deploy itself both. Actually, we'll go in and install a Helm chart with both for Windows and for Linux. This is the only step you need to do, and then it's those two added to your cluster. When you have that running in there, you also want to be try to deploy some cool stuff. This is not it. Let me show you how that actually works. If you come over, I can just give you the slides afterwards as well. So, what do I have here? Let me check. So now I want to deploy my. Actually, before I do that, let me just put some watching in here so I can actually see that I'm not cheating. Kube get pods wide and watch it. And let's actually do it for our services. Kube control get services override watch. So now I'm like watching all these, and now I'm just gonna go kube control, apply file, ACI. Let's take this one. This is more fun. There's more stuff in it. So now it's actually going to deploy. So what it actually does, if you look at the YAML stuff that I have in here, I'm actually selecting a node that will look at the Linux and look at the type of virtual kubelet. I also have a taint and toleration that it can only stuff that are virtual kubelet related can only use this one as well. Do you see the coupling now? So does that make sense? Good. Seeing people here or nodding their head. And now you can actually see that I'm starting to deploy some stuff up here. It's shooting up a few images, and I actually also shooted up a load balancer coming in here. And that's all nice, but so what's the typical use case? Well, think of it in case of, let's do something fun just to mess it up. Let's see if you can destroy it. Exit. So now, let me see if I have this. Cube, control, edit. Actually, you can also see that it's giving me an IP address. DNS just takes sometimes a bit of a while before it's updated, and actually before the website is loaded. So this is just a stupid hello world. But the idea is that with DNS just sometimes takes a bit in order to update itself, so I can actually reach it. But it's around, I don't know, 1 minute or so, and then it's typically running down. But the general idea is that you can have a lot of pods running inside of it. I think we usually cap it officially to 100. That's just to keep developers calm so they don't go crazy when they start deploying stuff. So if I go in and edit my deployment, can you remember what name it is? It's my hello world. And this is not recommended way of doing it, but I'm just going to do it just for fun. Let's see. I have 3 replicas in here. So let me just do 50 just for fun. And now this should go crazy over here. But now I'm basically just spinning up 50 container instances that is connected to my virtual kubelet, that is connected to my Kubernetes cluster. So now you can actually control everything from your Kubernetes cluster, which is quite nice. And I'm going to get a massive bill for this. By the way, we also bill per second the instances running. So just bear that in mind when you actually look at this. And you can see that it's starting to run up as well. Does this make sense? And this is also the same case when we come. So here it's actually running. So I'm just gonna let's keep it running. That's fine. Let me show you this as well. So here's an example I have running from my Windows. So in this case, I'm running a virtual kubelet, and it's just installing ISS on a nano server as well. And this is a good use case because you still have some ASP core stuff that you maybe want to be running in there, or you're doing some custom work that has these dependencies. So this is a thing that you also could consider as well. Kubernetes will also support Windows containers. In this current state, I wouldn't recommend it. This is the way I would recommend running it instead. Okay? It will come eventually, of course, with Microsoft, but it will come eventually. But this is the one I will go with. If you have something currently that you really, really need to run in a container instances, Service Fabric is the way to go. Okay? Service Fabric still takes Docker containers, it still takes VMs, and you can scale it unbelievably in there. So this is the way we'll typically recommend. Good. What's next on the agenda? Dev tools. So, Helm is a big thing as well. The guys actually building Azure Kubernetes Services is also the guys that actually invented Helm. Pretty cool guys, and we typically recommend it for a lot of stuff. It's a cool thing of deploying applications. It's a cool way of doing stuff. And honestly, I would recommend it for a lot of stuff. First of all, that we have when I do a Helm, one of the things I really, really like is our rollback functionalities. So you can deploy a chart, and let's do Helms search. I'll just show you how one looks like. SQL. Let's see, there should be a MySQL in here. Let me see here. Let's take this one, and I can do a Helm inspect. So what I do now, I actually go in and actually looks how this chart is written, what dependency this has. It's basically a package manager for Kubernetes. So you can build packages into a Helm chart, and the Helm chart would start installing itself into the cluster. That's the general idea. It's a super cool, neat tool, and when you write your chart, you can always come some recommendation, like if you have role-based access control enabled, how do you do certificate management and so forth. And this is a thing you can pop into the chart and share it, and there's a big community around this. So that's the general idea when you do this. And the rollback is another neat feature. And that's all good. Typically, I would also strongly recommend this if you do Azure DevOps. I should have that actually open here. Let me see if the window is still active. Here. So I can go in and build, I'm building a pipeline here, and I can go in and type my Helm. And what I need to do is type Helm in it, and Kubernetes will still automatically go out into and download the bits, and then you can start packaging everything up. This is what we recommend you guys doing every time you build a pipeline. It's helped a lot of customers in order to simplify out the whole stuff. So we just fill out the stuff. You can even go in and command, and also you can also build pretty advanced workflows saying if you need to upgrade it, if something goes wrong, you go in and call another chart and roll back the current deployment you have, and then you keep running as well. This is what we're also looking at. Another thing is also start using Terraform. Terraform is extremely sexy when it comes to doing ARM templates, replacement stuff. We see a lot of stuff. How many of you guys like ARM templates today? No one. One guy. Okay. But we're looking at if you can do Terraform in just a few declarative lines compared to a massive ARM template, it's pretty cool. We see a lot of customers starting to do that instead, and they keep, well, they actually fly over to our engineering department once in a while and start building the resource provider together with us and have that in there. So have a look at that as well when you start doing pipelines management. And that's all good. So we also have a service called Draft. Draft is an interesting concept. I actually like it. It is also trying to address developers. How can I do something faster? And in terms of best practices, how should I build my containers? How should I build my templates and so forth? So this is what I'm sort of trying to address now. Let's keep pressing this one. It's here. So I have a few demos up here. So let's see. I have one here. Now let's take my .NET up here. Let me go into this folder. So what I have in here is my .NET code, just doing some simple stuff. It's just a program running a web application, and it just has a hello world. And that's fine. But now what I want to do as a developer is I want to throw it into my Azure Container Registry. Actually, no, sorry. Taking a step back. What I want to be doing is I want to build a Docker file. I want to build a Helm chart. I want to shoot it into my container registry. And when it's done there, I want to shoot it into my AKS cluster. And I want to do that with 2 commands. Let's see how that works. So now, in order to actually just, is this readable? Oh, sorry. I see. Yeah. So draft init is basically it's basically the one that actually goes in and installs it. Now you have it running in your cluster. So and look at notice the folder on the left side. This is the folder that I'm in, just to make sure that I'm not cheating. So now I need to draft create. So what it actually does, it actually goes in and detects what language that I'm using with a 98% of certainty. And now you're right, actually the wrong directly. But you need to trust me, this works. Thank you. All right, I can do it again. So now I have a Docker file, and thanks for that, by the way. So the Docker file now creates all the stuff that I have in here. Considerations you need to figure out. Some of the stuff you need to consider is the image that I have in here, the Microsoft.NET 2.1 SDK. When you start building Docker containers, you don't want to have massive containers out there. You still want to have them being quite small. So you need to figure out what images do you want to be using. What libraries should it contain? That's something you need to consider when you actually do this. So So now I actually built the container. It actually also gave me a TOML file, which is the chart for Helm, and now that's running. And you can actually see it gives me a lot of cool Helm stuff in here, and so forth. That's fully automated. So the next command is draft up. So now what it's doing actually connects my Azure Container Registry. It shoots it in there, and actually, just so you don't think I'm cheating or lying, I'll show you my container registry here. Let's get that up and running here as well. And I have on my repo, and now it should be up here soon. Is that .NET? Yeah, it's actually there. So that's fine. So we can also see the logs. Actually, it should now have a lot of container instances running in here as well. So maybe I should have killed it off before. So let me go in and edit it as well. Just go in and kill all those. A lot of terminations. Cube, control, get, pods. Now I have a lot, a lot of terminating. Let's see if we can find it in here. So there should be a .NET. There we go. So this is the application. So what we did now, just to repeat, is we created the Docker file. We did the draft up, which basically shoots it into the container registry, and from the container registry, it shoots it into the AKS cluster as well. So if you need to testing how this basically works, that's all running in there. Did that make sense? Yeah? Good. All right. Let's continue. So how do I basically run a high availability cluster in Azure when you start building this? So one thing, now you look at the container space and that's all fine, and now you want to be doing some more advanced stuff when it runs in Azure. Typically, we see that you should, so clusters and Kubernetes cluster is fairly simple. That's where you have the applications running. But the real value is the value add you put on top of that. I've been working on some large projects where we have large supertanker vessels where you have low latency. How do you provision applications out there? You don't really shoot VMs over satellite connections. Well, you still have customers doing that, but we see, well, maybe we can do in Docker files instead. So you basically split the Docker file apart, take all the layers and shoot them through the line and assemble all the stuff on the boat. And now you have an application that's been updated on premises. But that's one thing. That's just basically Docker and management and CI/CD. But you want to have some cool stuff. Well, that's connecting it with AI, connecting it with stream analytics, looking at the data points putting into it, looking at IoT hubs, devices shooting data into a Kubernetes cluster so you can actually see, let's say, modify packages or doing some modification in any type of way. This is one cluster way of doing it, and that's typically what we also recommend of you guys doing. Going into a larger scale is things that you need to consider. Ingress, how should you be doing Ingress? How should we be doing enable communication? Depending on the devices, should it be a website and so forth. This is something you need to take serious. But also from a security point of view, there's a lot of security aspects you need to consider. And that's everything from securing the baseline of how you write your code, how you run it in a container, how you run it in a container, resource groups, communications, load balancers, firewalls on top of that. And then the last thing I have on my right side, which it's sort of a hidden way, is basically load balancing. So I have some of my customers that I'm working with is that they have a free cluster strategy. I typically recommend minimum of 2 in case of a disaster. That the traffic manager would actually take in, and depending on how you set it up, you can go to the one that actually, let's say, replies the fastest back would also be the one, the cluster you would go to. So typically in Europe, we will say one in North Europe, one in West Europe, and one in the US. That's one of my other customers are doing today. So that's one case you can actually do this. Does this make sense? What we also see is like, now I also want to be connecting to my Kubernetes cluster and I want to access this. This is where VNet and ExpressRoute comes in. So you can actually peer those. For you guys that don't know much about ExpressRoute, it's basically a WAN connection directly into Azure, and so you don't go over the internet to connect to Azure, but you can actually connect those to Kubernetes as well. So what else do we need to consider? When customers are spinning up Kubernetes, it comes out with a traditional Kubernetes RBAC. There's pros and cons of going with Kubernetes RBAC, but also going with AKS RBAC in terms of enabling Azure AD clusters. You should actually, it's missing an A up there. But what does this mean? That means now you can use your identity that actually exists in the cloud and use that for controlling who can access what on given resource on Azure, but also having the track record of activities, who's been doing what, deleting stuff and so forth. So that's one element. How we do this is basically just by shooting up the YAML file and then you enable that. Okay? This is what I typically see a lot of my customers liking. Here on the right side, I just have a few examples how you can do it from let's say a user-based, but also groups. So actually go in and take the ID of the given group, and now you enable those guys to access that. That's one thing, and that's basically just management of that. But what we really want to do is pod identity, MSI for Kubernetes clusters. How we do management of users, objects, accessing services running in the cloud. That's something that we're looking at, and we have that as an open source project running in terms of security, management, load balancing, and so forth. Questions so far? Good. All right. The last thing I want to talk about, monitoring, just quickly. We see monitoring being a quite critical path. So let me just drop this out and shoot it into Glacier. So this is a bit what we're going to be doing in the future. So a lot of customers are talking about, so when I'm running in Azure, I still want to be having a sense of security that I have in there. So what we have with Azure Security Center, and also something that will be container-based, is how we do compliance on Azure. How do I trust that Azure is doing its thing? This is where Azure Security Center is. In its current state, it only supports the nodes that we're running. That means the worker nodes. The worker nodes is one that hosts the containers. But we still want to be managing those. How do I patch those? How do I upgrade those? Who should be doing that? Should the developer do that, or should the infrastructure do that? So this things what we're doing here is actually capturing if you have packages missing, or if you have written some malicious code that someone got access to, and now you are talking to something that we know of is a dangerous IP address based on the data that we can collect from our crime unit in Redmond. So correlating those data paths is something that we strongly recommend customers going and enabling, especially if you're serving services to the outside world in Kubernetes. So this is actually just my last words, and I heard the other guys was clapping, so I will shut it off unless there's questions. Shoot. General tool, open source tool you can use on the AWS cloud. I prefer it if you choose Azure. Thank you. All right, I'm going to be in the booth, and thanks for having me.